Hi, and welcome to this lecture on sets. In this lecture, we are going to learn about what sets are, creating them, accessing them, adding set items, removing set items, looping, joining, and the built-in methods that come along with sets. And some common errors that people normally fall into. Okay, today let's open our script editor in a slightly different way. We're going to, with our mouse in the middle of our viewport, we're going to hold down spacebar, and we're going to go over to Panels, click in Panel, just like we would at the top left-hand corner we've done before. We're going to go down to Script Editor. Okay, and you'll see we have opened up everything that we've got that we need. Okay, let's clear our history from the window and check that within history we have line numbers in errors ticked on and show stack trace ticked on. Okay, great. So what are Python sets? Let's have a look. So Python sets are a way of storing and organizing data in Python. They allow you to store a collection of unique items in a single variable. So imagine you have a list of phone numbers of your friends and you want to remove any duplicates so that you only have one entry for each friend. You could create a Python set with the phone numbers as elements, and this will then only keep the original numbers. Okay, so sets are one of the 4 built-in data types in Python that stores collections of data, the other 3 being lists, tuples, and dictionary. Now, these all have different scope, as we have seen so far. So let's have a look at creating some sets. Oh, and some key features. We should try and I'll keep this going for the rest of the lectures. But the key features of sets are that they are immutable, they are unordered, okay, and they do not allow duplicates. Okay, so let's have a quick look at now creating some sets. All right, so sets are written using curly brackets. So we have our first set. We're going to call this our set using our great imagination. Okay, and within this set, okay, we encapsulate these these items using, okay, the curly brackets. So very similar to dictionaries, though unlike dictionaries, we don't have any key value pairs. We just have the essentially the items themselves spaced, separated by commas. Okay, so unlike with dictionaries where you have the colon and then you have another item, so sphere and whatever else it might be. So foo, okay, that would be the way that you make a dictionary. But here, this is a set. We are just going to have the items encapsulated, okay, with the curly brackets. Okay, and this tells Python that this is a set. So let's print this. Okay, and we're printing out our set, plane, cube, and sphere. Okay, great. So we could also just check and see what it says about our type. And this is a class type of set. Okay, so yeah, that's pretty much all you need to do to create a set. Very simple, very straightforward. So as we've said, set items are unordered, they're unchangeable, and they do not allow duplicate items. So, all right, let's try and add a duplicate here. This is where generally you'll find the use in these, that they're very powerful in organizing data and removing duplicates or gaining all the items that have duplicates. So the scope of these is quite specific, okay? So I've got 2 sphere items now. So let's see what happens. Yep, we just get the 1. Okay. All right, let's have a little look at another case. So let's, in this instance, we're going to add true. So remember, we can have any data type within here, and we're also going to have 1. Now, one thing to note is that true and 1 are actually seen as the same by Python. As we said within the Boolean section, true and 1 are kind of noticed within expressions as true, or as an expression of true or truth. But within sets where they're not allowing duplicates, you cannot have a true Boolean statement alongside a 1 integer, because they are actually both seen by sets as an expression of truth. All right, let's get the length of the set then. So nice easy one here. Okay, again, we're just using our Python method, len, okay, short for length. Okay, and we get a length of 4 for this set. Okay, nice and straightforward. Okay, so let's look at what sets can contain. So they can contain pretty much anything, but they cannot contain lists or dictionaries. So let's see what happens if we add a little list in here. It's an unhashable type. Okay, can't do that. Okay, and it's pretty much the same if we add a little dictionary. So let's put another type in here. We'll do, okay, we, and then work. Okay. Nope, another unhashable type. Okay, we can't use a dictionary either, but we can use true. Okay, we can use integers. Okay, and you see they'll all print out. But as we've said, any duplicates will not be shown in here. Okay, so if we did another true, let's see, if we just copy these and we just put these to the end. See, it's not going to change our list because we can't have these duplicates. It's just going to not look at these. Okay. All right. So it is also possible to create a set using the set constructor. Okay, as we've done with lists and dictionaries. Okay. I would say it probably doesn't look as nice though. So let's create a set with the constructor. I wouldn't say that readability is increased by this, so I wouldn't see the point too much. Okay. So we've got our set constructor, gives us, if we just highlight and press Control Enter, we get our class type of set. So this is our constructor. And now we're going to enter the whole thing. Ooh, what have I done here? Ah, sorry. Okay, I'm missing a bracket, missing a parenthesis, sorry. Here we go. Okay, so now we've got our set, which has been created with the constructor. Okay, and you see there we've got the curly brackets showing us that this is a set. But okay, I'd say that the double round brackets probably say that I would say that this doesn't increase readability, so I wouldn't say there'd be too much point. Yes, we can see that this isn't explicitly a set, but what we are doing is passing a tuple, and then we are asking for the tuple to be converted into a set. So we're kind of doing two operations on one line, which again, it won't matter for 99.99% of situations. Sorry, just moving myself in my chair if you wonder what that weird squeaking was. It's not wind, I swear. Okay. But okay, where was I? Sorry, but what I was saying was but because we're not increasing readability, it's really not worth it. Okay, because we're running two operations, essentially, we're going to increase runtime, which again, like I said, won't matter in 99.9% of scenarios. But if you are running big data projects, or if you are running operations with huge amounts of time lag because there's so much going on, things like this, everything starts adding up. Okay, so you want to try and run things the most efficient way possible. Okay, all right, let's move on. Let's look at accessing. Sorry if my throat feels a bit croaky today. It's been a long day with a few meetings at work, so I had to do more talking than I generally care to. I prefer just to actually get on with work. But okay, let's have a little look at accessing. Let's clear our window at the top as well, clear our history of the output window. Okay, so let's look at accessing these loops. So let's go back and let's add our sphere, cube, and plane set in. So one way we can look through these sets is by looping through them. Okay, again, we're going to go into loops in more detail later on. So let's give our proper indentation here. In my notes, it's actually not indented properly, but okay. So we've got our set. Now let's loop through our set. So you see, we've printed out everything. Now, as these are unordered, okay, you've got to remember that this might not print out the same every time if you reconstruct this set, but it will also is not something you could guarantee against. So just remember that being unordered means you cannot guarantee what will come where. Okay, if you want something ordered, use a set. Okay, and remember with this we have got the X, which we are going to print. So we are saying for each item within our set. So we could even go for I. So for each item, we could even just state for each item within our set. Okay, and this will loop through our set. Okay, print that item. Okay, very straightforward, very simple. Okay, we could access our set by also checking what is in it. So we could print, okay, an expression and go, let's see, is tube in our set? False, it's not. Okay, so similar with a list. Okay, we can check if an item is within our set. So let's explicitly look for sphere. True. Okay, what about sphere with the uppercase? What have we learned so far about items with an uppercase? False. Okay, sphere uppercase is not in there. Okay, these items are case sensitive. Okay, got to remember that. All right. Okay, let's have a little look at adding set items now. Okay. So again, we'll go back to having our set. And yeah, well, let's go ahead and add the tube that we were talking about in the last one. So literally, as we said, we're going to add tube. Okay. Now, let's see what the output is. Okay, so again, highlighting, pressing Control Enter. Sorry, I'm kind of just forgetting to say this, but yeah, highlight the code, press Control Enter, hold Control and press Enter. And now we look what we've done. We've extended our set out, okay, and we've added the tube item. Okay, perfect. All right, so let's update our set now. Okay, let's see what happens here. Okay, we can also add elements from our new set into our current set, but just remembering that duplicates will be lost. Okay, so let's create a new set. Let's go for a really complicated name as new set. Sorry, I am tired and I sometimes get sarcastic when I'm tired. Okay, well, what else we put? Star. Oof, it's a big uppercase star. Okay, and a classic teapot. Okay. All right, now let's go for our set. We're going to update with the new set. Okay, great. So we've got all the items there. Okay, simple as that. All right. Now let's see what happens if we have a duplicate item. So let's put 2 cubes in. So we've got cube in the first, cube in the second. What happens? We only have 1 cube. Okay, great. We've lost our cube. So just remember, you can't have duplicates. So very straightforward. You can't do anything okay with that. All right. So that's adding set items. So very simply, you have add or update. Okay, not a huge amount of methodologies, but yeah, I mean, they do what they say on the tin. Pretty straightforward. That's how you add to a set. Now let's look at removing from a set. Okay, so okay, we've had update. Now we're just going to literally put in remove, select our item, okay, and then say remove. So simple, okay, our set. So our set dot remove, okay, plain. Okay, easily. It's just removed it. Easy. It's just removed it. Okay, I mean, it's not much to say about that. We can also use the discard method. Okay. Okay, so the good thing though about remove, if it does not exist, remove will remain or will raise an error. So depending on your case, okay, on the case that you would like to use this for, you may or may not want an error. Okay, so let's try and remove plain 1. Okay, there's no plain 1 in there, but yeah, it gives us a key error, okay? This key cannot be found within our set. So that is one of the good things about this. But if we use discard, you'll see actually we don't get an error here. So it really depends on whether you want your a failure of an action to result in an error or not result in an error. Okay, obviously there's different cases for each of these examples. So really depending on your script. If you need a user to know that what they've done has resulted in an error or that something has not happened which you need to happen, I would raise an error and let them know that so they can read that in the stack trace and go, I should have done this. Okay, or vice versa. If it doesn't matter, if that item doesn't exist in a list you're appending, okay, or removing from it, yeah, just let it fail silently. Okay, it really depends on the case for that example. Okay, so that's remove and discard there. All right, and then very similar to lists, we can also pop an item. So if the item is found, again, and we can actually hold on to it. So let's do that as well. So popped. So let's go. Oof, okay, so what we've got here, got, oh, I remember now. Sorry, I mean, this is my memory. Here we go. I need to write a note on this. Okay, so pop actually removes a random item. Okay, that I've got to remember. So unlike with set, or with dictionaries or with lists or tuples, you can you explicitly state what you want to remove. But here you're going to remove a random item. Okay, so every time we pop something, it's going to be another random item. Okay, so we've eventually removed everything, but I don't exactly know the case of this. I mean, there will be a random time if you are writing a script. You'll need to remove a random item, but probably why I've forgotten this, because I don't think I've ever used this in my script. So obviously, generally everything we're doing in rigging or within Maya, as a TD, you're kind of doing it because you have the you're explicitly wanting an action to happen. You're very randomly, or very rarely, are you going to be doing random actions within your scenes, unless it's building, random trees. I suppose maybe that's a scenario for this. Maybe you want to have a scene where you remove random trees. You want to create a list or a set of your trees, but you want to remove a couple. This is one way that you could remove some of those trees from the list and then just delete them afterwards if they don't exist within this set. Yeah, so maybe that's a case example, but yeah, I mean, it's very random. So you can pop and then remove items. And obviously then if we look at our set now, the set is empty. Okay, there's nothing left in our set. But let's see if it pops the same item again. Yeah, it did plain again. Let's run it again. Yeah, it seems to be doing the same item every time. So there is some indexing happening within Python, but again, it'll be random for every time that you create a set with different items in different orders. That's the best way to remember this. Okay. So clear. Yep, clear definitely works in the same way that we have looked at within dictionaries. Okay, we'll just clear your set. So you've initiated our set. We have initiated our set. Okay, our set contains everything we need. We're not actually popping anything now. Sorry, that should be removed. Okay, and now we are going to go our set, or our set, or I should enunciate, our set dot clear. Okay, so what this leaves us with is an empty set. Okay, very relatively straightforward. And delete, again, very much the same as we looked at in the previous modules. Okay, this actually deletes our set in its entirety from Python's memory. So, yep, we get a name error now because our item is not defined anymore. Okay, we would need to redefine this set. Okay. All right, so if you need to delete it, okay, like we're going to be doing in our class methodology later, then this method is good. Deletes everything from Python memory. It's useful for us, okay, when we're using Pythonic systems. Saves us on memory, means that we're not just leaving items within Python's memory and then running scripts that could run for days. You know, if you're running a Python library you never want to shut down, and running scripts continuously, you generally don't want any item that's been removed just to exist within Python's memory. You would want to delete that item, the variable, and all the data that is associated with it. Okay, that is where the delete method comes in very useful. Okay, it's to stopping a memory leak, essentially, well, a human error causing a memory leak there. Okay, let's have a look at looping. So we've already touched on this, but looping, relatively straightforward, as we showed above. It can be done by either typing what we did before. Okay, so our set, okay, sphere, cube, plane for X in our set, or for item in our set, print the item. Okay, there we go. So we've executed our code with holding down control and pressing enter. We are then looking at the code that has been executed and the output of that code within the window. Okay, very straightforward. But we can also use list comprehension. So let's use this other methodology and let's go for what we learned before. Okay, so again, this is going to transfer everything into a list, but this has its case, has its cases as well, where this will be useful for you. So let's have a look. So I for I in our set. Let's print this as well. Okay, so now we've got a list of plane, cube, and sphere. So another way of looping through the items within our set. And obviously the good thing about this is that we could also do maybe a little kind of a little condition in there. With the expression, let's look for any items that have ER in them. Okay. And look, we only get sphere. Okay, nothing else has ER in it. Okay, so one way of working with sets, so you can always use a set to maybe remove the duplicates within your scene, within a group of items that you're collecting, and then use a list comprehension just to cycle through them and get every item within the condition that you're setting there, and then assign that to a variable. We'll call this our list items. Okay, and now our list items from our set is stored there. Okay, the only one left over being sphere because it's the only one with ER in it. So we've got I for I in our set looping through. Remember, this is the only part of the set which will output for us. Okay, and then we have the condition with the expression if ER lowercase is in I, okay, then print out. Okay, so if this condition is not met, you will not get anything outputting on this side. Okay, so if we remove this condition, okay, and then we get plane, cube, and sphere. Okay, everything is now past the condition because we have no condition in there. We're just looping through our set. Okay, let's go through and on to joining. Okay, so joining sets in Python, you can either call the union method to create a new set with all the items from both sets, obviously if there aren't any duplicates, or you can use the update method to add one set's items to another. The choice is yours. So let's go ahead and kind of work. Actually, I was going to say a pun there. God, I was going to say settle, and then I realized as I was saying it, this is the worst pun in the world. So God no. Okay, but anyway, let's use the union method anyway. All right, so let's go for set 1. What should we make this? Let's just go with 1, 2, 3. I'll go set 2. Sorry, it has been a long day and my typing has gone to pot. Okay, so let's go for set 3. Okay, set 3 is going to be the union of these two sets. So we're going to say set 1, okay, dot union. And then we're going to add that with set 2. All right, so now let's print set 3. So what do we get here? So again, you see, again, it is funny with sets, but we have what again looks like ordering, but just remember it's not. Okay, it's just coincidence. And then we have CAV. So again, that's not ordered. So even though it looks like it is a little bit, okay. But what we've got here is the union of both of these sets. So if we add 2 to this set, okay, it doesn't affect anything because we have already got a 2. Okay, so we're just picking up this first 2. This second one will just be discarded because we're not going to look at it. Can't have duplicates. Okay, so that's the union method. We can also use the update method. And this will, again, inserts the items from set 2 into set 1. So, okay, let's see what we get. Oh, wait, I have got an error here. Ah, of course, sorry. So again, we shouldn't be assigning this to a variable. I'm trying to rush through. So this is a set method, but again, it doesn't give us, or it doesn't return us anything. So you'll see that set 3 is actually obviously then being returned none because it's got nothing. There is nothing returned by the action of updating set 1. So what we're actually doing, sorry, is updating set 1 here. Okay, and you see very similar. Okay, we've got the same pretty much output there. Okay, so let's keep the items that exist in both sets X and Y. So let's do an intersection update. Again, these are going to be some interesting methods we're going to talk about now, but I would write notes on them because these are very useful in very extreme scenarios. Like I remember the most I've used sets is when I was making some scripts for an advert where there was an exploding, I think there were 2 exploding situations actually, where one was an exploding engine and one was an exploding meteorite. So I had to write a script that exploded everything, set it to random positions within certain boundaries within a scene, and then animated between those positions, making sure they didn't intersect. And then I ended up using sets quite a lot because obviously I was using that parameter. I wanted to make sure that there were no duplicate names, there were no duplicate items within the scene, and there were no duplicate positions or intersections, which is where sets can become very useful. But okay, anyway, that was just a bit of the method behind the madness of sets, okay? Because you'll use these a lot more in big data than you might do within Maya, but they're still very useful to know. So that's why we're going to run through these. Okay, so let's give ourselves 2 lists. We're going to go with X and Y here. So our list X has our sphere, cube, and plane, and Y has box, cube, and teapot. Okay, you probably already spotted our duplicates here. Okay, but now what we can do is go X dot intersection, and then we go underscore update. Okay, so update with Y. So this is going to keep the items that exist in both X, okay, and in set Y. Okay, so the only items that exist in both sets are the cube. So this has kept them. Okay, see, again, it's a very case-by-case kind of point here. This is a very useful methodology to have, but it's a very niche case. So you will need to use it at some point, and you'll end up probably trying to write logic that does it in a few lines. Whereas if you remember what you can do with some methodologies, like with sets, you can just do it straight away. It's a built-in method. So I just always remember to take notes and try to refer back to them at certain points. Okay, so now let's create a new set. Okay, we're going to create a set Z. Okay, and this time we're going to use an intersection method. Okay, and this is going to return us a new set that contains the items that exist in both sets X and Y. So the intersection method, okay, is just exactly the same, but now we're not using the update. We are just creating a new set. Okay, so instead of updating, we're now creating a new set. Okay, so very similar methodology. You either have intersection update or intersection itself. Okay, it's good to remember though. Okay, and we've got a few like that now. Okay, so let's keep the items that are not present in both sets now. So let's do the opposite of what we've just done. So for this one, we have symmetric difference. Okay, let's make sure I spell this properly. Okay, let's hope for the best with my spelling. So, okay, as we did before, okay, we just kept the items that were the same, but let's see what happens now. Okay, now we've done the opposite, as we said. Okay, anything that is not the same has been kept. Okay, so we've got 2 matching cubes, so they've been just kicked out. Okay, but we've got everything else that does not match up. All right, so now let's do the same as we did before. Remove the update, assign this to a variable Z, and then let's print Z. Okay. All right, same thing, but now we've got a variable with it. So it really depends again on the case. You can either whether you need this, whether you need to do these methodologies or use these methodologies, or whether you need to assign them to a variable. Okay, very powerful, but they just have different different scopes. Okay, and different cases that they can be used in. Okay, so let's have a look at a different example. So let's do a sphere, cube, plane. We'll also go with true, and now we'll also add 1 and 2 over here. Okay, All right, let's go with Z again, getting our symmetric difference. Okay, assigning it to Z. Okay, and now what have we got? So again, we've got spheres now at the end. Okay, see, so we're definitely not in an ordered list. Okay, we haven't kept one or true because these have been seen as the same thing. Okay, and cube is also gone. So that's again, this is where you just have to remember these edge cases, okay? Because this is very useful for specific cases. But if you do have lists with true and one in them, and then you're wondering why they're not happening, why the script is not outputting what you're expecting, then just have to try and remember back to these notes, okay? Symmetric difference, okay, gives us everything that we need, everything that is not matching, okay, back to us, okay? And items that are obviously not duplicated because sets cannot have duplicates, okay? All right. Okay, nice one. I hope you've stayed with me on that one. Sets are a bit more confusing than maybe some of our other methodologies that we've looked at, but just as powerful, and especially within their cases. Save. Okay, so let's have a look at some of the built-in methods that we've covered in this lecture. Okay, we've looked at the add, okay, functionality. Okay, this just adds an element to a set. We've looked at the clear, which is again very similar to list and dictionaries. It just removes all the elements from a set. We've looked at copy, which again, it doesn't reference an item. It creates a brand new copy of it. Okay, very useful and important for you to remember. Okay, we have looked at difference. Okay, returning a set that contains the difference between the two sets, well, or more. Okay, we've looked at discard. Okay. We've also looked at remove. Okay, remembering that remove gives us an error. Okay, but discard does not. Okay, we've got intersection. Okay, returning us a set with the intersection of the other sets. Okay, we've also got intersection update. Okay, again, very useful to know the cases for these items along with symmetric difference. Defer, rinse, there we go. Okay, which we can either have an update with. Okay, always end up putting too many F's when I do things like this, but especially when I'm tired. Okay, so we've got symmetric difference update. Okay, we've also got symmetric difference, obviously, then where we can assign it to a variable. So remember, the update does it to the item that we are updating, okay, at the beginning where we are calling it. So as we did with X, we've got the item X, which, okay, if we have update at the end, okay, we are updating X, okay? If not, then we are assigning this to a brand new variable, okay, to make the changes to. Okay, we've also looked at, what other methodology we look at? Yes, union. Okay, okay, adding two sets together and update. I'm not sure if I said update already. Oh, that was terribly written. Update. Okay, so that's pretty much everything. I'm not sure if there's anything I'm forgetting, but I'm pretty sure that's everything. So we've done quite a lot here. So yeah, you might have to run through these a few times. I'd recommend W3 Schools again, going reading a bit more into the information about these. Maybe, yeah, maybe run through a few examples of these. Look at Stack Overflow. Okay, but these are very powerful things and do have their cases. Okay, all right. So let's look at some common errors that can that can occur when you are creating and working with sets. Okay, so main one, as we looked at the beginning, is not using curly brackets or braces. Oh, Lord. Okay, pretty sure braces probably actually works as well, but I feel like I meant to write brackets there. Okay, so not using curly brackets to create a set, and maybe using just parentheses, which will obviously just create you a tuple, okay, or using square brackets, which will create a list. Okay, so again, easy to do, okay, but you've just got to remember, you've got to keep your eye sharp on those, okay? They're very small, very small differences within the scene, just a few pixels difference, but they are important still. Okay. And then remembering you can also use the set function just to create your set, but then you're using double parentheses, so maybe not as readable. Okay, modifying a set again while iterating over it, similar to dictionaries, lists, tuples. Make sure that you are not iterating over a list or a set or a dictionary, any of our collections of data, while then making changes to that data, okay? Because you will get errors and you will cause yourself a nightmare, especially on an unordered set like these, because you're just going to, again, not know what you're working on next within the loop, okay? So using the wrong set method, I mean, that's very easy to do. I've definitely done that before when I was first starting out with Python. Just make sure you check your notes. I mean, God, it's been a long time since I've really had to use sets, I think, at the minute. But I definitely would probably go and check my notes to remind myself of exactly how I wanted to work with them if I needed to again, okay? So yeah, I think that's pretty much everything. I'm trying to think of any other cases, but I can't. But okay, so thank you for sticking with me on that. Not an easy one, I know. But in this video, we have learned about, okay, what are sets? We've looked at creating them, accessing them, changing them. Okay, we've looked at adding items to them, removing set items, looping, joining, built-in set methods, and some common errors. Okay, so thank you very much for listening, and I look forward to seeing you on our next video.